All right. So our goal for today, your I can statement, it's right on your tracking sheet. It says, I can simplify and find equivalent fractions. Kids, this is something that I know everyone in here has already done. Okay? But there's a few things that we're going to add to this that especially later on in the year, we're going to start talking about. We're going to take fractions and we're going to say fractions are part of a category called ratios. And we can use the same rules for ratios as we can for fractions. And one of the best ways we can use is the way that we figure out fractions. And it's a way many of you already know. We're going to talk about that in just a second. Here's the terms that we need to know. Equivalent fractions, and all it means, equivalent means equal. Can we create equal fractions? Fractions that are the same. Their numerators and denominators aren't going to be the same, but they represent the same amount as compared to one whole. Makes sense to everybody. Okay? Who can give me some equivalent fractions that they know for sure? Give me two fractions that they know are equal. Because if we make one whole, out of one whole, and we show that representation, even though they don't have the same numerators and denominators, they're the exact same. Yeah. In the way back, Miko? Never mind? All right, go ahead, Allie. Everybody, that was 1/2 and 2/4. Are those two fractions equal? Yeah. If we're going to draw that, and kids, we are going to spend some time drawing fractions. If we said 1/2, that would represent that portion, right? One part out of two. Now, if I make the exact same square as one whole, and now I split it up into fourths rather than to halves, there's 2 out of 4, and it shows the exact same amount. Okay? So that's going to be our goal today, to be able to show those equal representations of fractions. Then we also need to know, the dreaded term that no one likes, simplest form. Okay? Simplest form is basically when we simplify a fraction down to its lowest terms. Okay? 2/4 is not in its simplest form. 1/2 is. Okay? So the definition is a fraction in which the greatest common factor of the numerator and denominator is 1. So we can't bring that down anymore, and we'll talk about this. So what I want you to do right now in your notebooks is this. Here I have some equivalent fractions. I do. I have a numerator on top. Here's all the numerators. Here's all the denominators on the bottom. Okay? I want you to just list what patterns do you see. I'm going to give you a few moments, and then we're going to talk about them. What patterns do you see? All right, who can tell me one pattern that they see? Go ahead. Does everybody see that? He said 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times. So, Robert, if we went to and I said, all right, if our numerator is 100, what does our denominator have to be? Base 500. Would everybody agree? Okay. So in other words, if you guys remember that from last year, and this goes way beyond what we're doing right now, but that's what's my rule. Do you remember that? What's my rule? And we take our input value, we multiply it by 5, and we get our output value. Okay? Now I'm going to do something, this is way beyond what we need to know, but X and Y, I'm going to call these X and Y. Okay? And Y is our output value. Our output value is equal to 5 times our input value. Does that make sense? And kids, that's called a function. That's something we're going to have to know this year for our MCA tests, and we'll get to that soon and very soon. Okay? And then we could go and we could graph all of these, couldn't we? If we have an X value and a Y value, we have an ordered pair of 1, 5, and we could put that right on a coordinate plane. And that's something you're going to have to do on your MCAs. Anybody else see any other patterns? Anybody else see any other? Go ahead. I'm going to help you here. He's saying going from right here, we multiplied by 2. So that means down here we have to multiply by 2. That's a rule that will work every single time for equivalent fractions. Whatever you do to the top, you have to do to the bottom. Now I'm going to tell you right now, it only works through multiplication. We can't add or subtract. Okay? And so if we go even further, if we go from 1 to 3, we multiplied by 3. So 5 times 3 is 15. And it works for all these. Even look at this one, all the way to 100. 1 times 100 is 100. 5 times 100, times 100 is 500. It works for every one. Now I want to show you something else too, real quick. We can also go the opposite way. If we go from big number to small number, if I take 100 and want to get it all the way down to 1, I would take 100 and divide it. So go from this way. Divide by 100, I get 1. And 500 divided by 100 gives us 5. So it works both ways. All right? Any other patterns that we see? Robert?
So if you see numerator, 1 plus 4 equals 5, and 2 plus 8 equals 10. Then 3 plus 12 equals 15, so every time it's adding 4.
Okay, so you're, sorry, say again, you did what? Where'd you start? 1 plus 5? 1 plus 4.
Like 1 plus 4 equals 5. Like 1, and then it's like 1 the numerator. Yeah, plus 3 plus 4 equals 5. And then 2 plus 8 equals 10. 3 plus 12 equals 15.
Okay, so he's saying plus 4, plus 8, plus 12, plus 16. So we're going up by 4 every single time and adding. Okay, very good. All right, one more. Go ahead, Marwan.
In the denominator, it adds every 5.
Everybody see that?
Adds 5.
And I want to show you this. This is an important one. 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. 20 plus 5 is 25. It works when these numbers are in consecutive order on the top. Okay? And that plus 5 is right here in your rule. And we talked about that earlier this year. Okay? Moving on. Moving on. Okay, so here's what we have to know about equivalent fractions. Here are all the things. Fractions that have the exact same value are equivalent. And there's a couple different ways that we can do this. Kids, we can go back to what we did in lesson 4.4. And that is find your decimal number. I guarantee that 3/4, 3 divided by 4, is going to give you the same decimal number as 6 divided by 8. And both of them will be equal to 0.75 or 75/100ths. In fact, I can prove that 3/4 equals 75/100 because we do 4 times 25 and we do 3 times 25, and there we go, 75/100ths. There's the exact decimal number. Okay? So we can use these fraction strips like you see up here. Does everybody see how 2/8 is equal to 1/4? Everybody see that? 2/8 is the same thing as 1/4 up there. So in other words, if we want to make 3/4, I can see that there's 2/8 here, plus 2 more eighths is 4/8, plus 2 more eighths is 6/8. So I can use fraction strips if I'd like to show equivalent fractions. Okay? Or we can use the rule that we just talked about. if we have a fraction and then we're missing one number, we can just find the magic number. What do we have to do to 3 to make it 12? What do we have to do to 3 to make it 12? Times 4. So if we multiply by 4 on the bottom, we have to multiply by 4 on the top, and we'll get a grand total of 8/12. Are we okay with that? Okay? So there's going to be a couple of different things that we can do in a couple different ways. So one of the rules that we talked about, I've already shared, whatever you do to the top, you must do the bottom. And here, we get kind of a funny word here. You guys will like this one. This only works with multiplication and division. That means it's multiplicative. Okay? In fact, I typed in multiplicative. I know it's a word. But I don't think Bill Gates knows that it's a word because it underlined my word and said that it's spelled incorrectly. I know it's a word, though. Okay? All right. So now, let's see if you guys can do this. Can you find two equivalent fractions for each fraction? Tell me two that are equal to 3/6. Tell me two that are equal to 4/7 and two that are equal to 11/13. Okay? I'm going to give you a few. Now, at least that part is recorded. Now let's try some story problems. Okay? Some application problems. We need to do these every single day. Okay? So, here's the first one. And we're going to talk about solving the first one, then I'm going to hit stop. Billy had 24 trading cards. He gave 7 of his cards to Miko and 9 of his cards to Terry. What fraction of his original cards does Billy have left? Write two equivalent fractions for that amount. Okay? So, let's talk about how do we attack these problems. One method we've talked about is we should underline. I'll wait until it's quiet. Still waiting. How about we get the important information out of here? Okay? It's 24 trading cards. Is that important? Yeah. Yeah, what does it represent? Say it again. 24 is the total, so he's starting with 24. And kids, I would write down little notes like this when we do these. Write down little notes. The greatest thing about these story problems is we get to be like little detectives. Find the information in here and solve that problem. Okay? It says he gave 7. I underlined gave. What does that do to our total if we give 7 of the cards away? Yeah. Sure. So now we're going to say he gave 7, so that means we subtract 7. How many cards do we have left? 17 cards remain. Okay? And then he gave 9 of his cards to Terry. So what do we have to do with 9 now? Subtract 9. How many total does he have left? Miko? 8 cards are left. Now, whenever we're talking about fractions, we're talking about part to whole relationship. The whole is our total. We started with 24. What does he have left? 8/24 is the fraction that he has of cards left from where he started. Because this is what it says. What fraction of his original 24, that's 24, does Billy have left? He has 8 out of 24. Everybody agree? Now it says write 2 equivalent fractions for this amount. Who can tell me one equivalent fraction that's equal to 8/24? Yeah. Oh, it's his favorite one. 80 out of 240. Good. He used one of the methods from before. Go on. 16 out of what? 48. Now, can we do simplest? Can we put this in its simplest form? 8 out of 24. David, do you have the simplest form? 3 out of 8. Well, let's see here, David. I think you're close. If we divide 8 by 8, we would get 1. And then take 24 and divide it by 8, and we would get 3. So you're really close. Okay? I see what you did by getting 3/8. Okay? But if we divide the top and bottom by 8, we'd get the same thing, all right? So now we got more than 2 than what we actually need. Any one of those answers would be okay. All right? I'd like everybody to try number 21 right now. I'd like everyone to open up their textbooks, please. We will be doing page 174. We'll do 26 through 42 even. And then the spiral review. And the spiral review is 44 through 53 all.